Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365. In Module 2, we discussed about best first search. In previous lecture, we discussed about best first search algorithm in AI. Now we discuss part B about the example explanation, example problem. So let's go topic. What's our example? In previous lecture, we also discussed the example lecture. So once again, I repeat it. So input, we have input source equal to zero, right? We have a starting node zero and target like goal node as nine. So this is our inputs. We have to adjust list. So like we want to create a path. From this path, we can easily consider to reach easily. We can reach our goal state, and we print the output as we print the output easily, right? What's the output of 0, 1, 3, 2, 8, 9. So we want to print this output. Why we did it as theoretically, but we won't did it in practical. So in this topic, we will do practical. This example problem in Python. So, explanation following describe the working of best first search, right? So we already discussed it. It starts from the zero node among its neighbors. So node one has to lowest cost edge, and we discuss about the what the from start from the first node. It takes the least value. So after it chooses for node zero, choose the next neighbor, and the edge cost five and three move to the three because three is to five. We have the least number as three. It moves the less number and at the 3 find the moving to the node 2 with the lowest incremental cost. So this process from to 2 to 9 it finally reached the 8 to 9. It is a target our goal state like that. So let's proceed the process. Let's move into the VS Code. So here we created again best fs dot py. So let's go into the topic. So first we want to perform first which function we are running. We are running a function called function to perform best first search, right? So, I take in this, I will consider a PQ we call no sorry, okay. In this function we consider the heap. Heap queue. We import the heap push and heap pop. Okay. So while we are pushing and we are popping, we are entering some values and we are popping the values, deleting the values. So from that I will take the heap. From heap, it is an inbuilt function we have inbuilt module heap queue. So from heap queue, I am importing heap push. Here you see automatic then heap push and the heap pop because I want to push and pop the values, right? So for this, I'm considering a function called best first. Best first search, and here I want to considering the edges, src source, the target here and here. So here we created it and now we want to move it. So we want to do another thing. We want to create the adjacent, right? We want to create the adjacent list. So like we want to for creating adjacent list, we can consider here like okay. ADJ adjacent equal to I will considering first a list. In that I will considering empty list. I use list compression here for dash not like that for dash in range n So here for edge in, from a considering edge in edges. So now here I'm adding adjacent value here. Adjacent edges start from zero. Lot for edge start from zero, and I'm appending that to append to my existing edge one comma edge two. Okay. So same process I will done from again one to two. So it also same process for one, and here including zero and two. Okay, it is same. So here I will create the adjacent path. So now here I want to create a visited, right? And we want to create a visited array here for y to keep track of visited, because if we visited, we want to if it is visited equal to true, visited equal to false, like that we want to consider here. So if we visited here, we want to track of visit nodes, and we can consider here visited equal to false. First I am considering false into my numbers. So here I created it, and I want to make sure that for again I want to create the min heap to store the nodes, right? So based on the cost. Cost is nothing but value more value value weight. So PQ here my PQ equal, I'm creating variable PQ. It has empty list here, and then I'm push the source node in the min height. Okay. Here I use keep pushing PQ. If a value visited, I want to push it, right. So PQ from 0 SRC. So from here, I want to mark that visited, mark the source node as visited, right. So keep for visited, I will equal to visited equal to true. So here visited my SRC equal to true. If not, it gets false. So to store, I want to create a path, right. To store the path, I want to first create a path. So for that, I'm creating a path has a variable to store. I'm creating empty list to store it nowadays. So here I'm considering a loop until the min heap is empty, right? So while PQ, get the top element. So it's equal to heap for PQ1, and here puts the current node in the path. So for pushing, I want to when I x equal to heap pop, I am popping the one, popping the each and where values. If it is already reached queues already visited. If you visit the next neighbor, I want to pop that in if PQ values. So for that, push the current node in the path. So I want to create a path dot append. I want to append those values in X. Right. So here I want to here take I want my current node. I want to consider another call. Like if my current node, like if the current node is a target node, so I want to break it, right, break the loop. If I will reach the target node, what will I will explore, I will complete my process. So for that, I want to breaking the loop. So if x equal to reach the target, I want to break it. I want to break the loop. Then the loop through the edges of the current node. So from for here, I want to consider for edge in ADJ. I'm considering X here, and if not in ADJ, I'm considering, I don't know, if not in AJ, I want to consider not HA. So what we'll do here, if they did not in present in edge, so edge in, I will not consider, if not visited, right? If not visited, edge, not visited from zero. So I want to mark that node slash visited, right? So I want to mark it with edge, visit edge dot edge zero and equal to true. Then I want to push the heap, mm, push the node in the main heap. So we push, and he push, I take PQ from my list in that I consider again H1. So after H1, I will consider it again H0. Okay, now it's confirmed. So I want to return it. I want to return path. So yeah, half of my code is done here. So here I will consider if name, okay, if name main, main, if name equal to main, we'll consider n equal to 14 and it will edg edge list equal to, I enter the edge list here. So what are my edge lists? 0, comma 1, comma 3. Want to enter those edge lists here. Okay, wait, it takes a time. I will make it fast. Yeah. So this is my list. I'll consider my list. And here I want to consider the starting. Here my target. We all know that our source is equal to our zero, right? And our target equal to 9. And we know that path equal to best first search here. And edge list is for your source and our target. And finally n. So for I in, and take the length of the path. Okay. Here I am finally I'm printing path of I, mm, and so then check while it's running. So we can see here how we get the output as 0, 1, 3, 2, 8, 9, right? So this is our output. So this is our output. We want to get it final output here. So we get the output here. So, and thank you guys. I hope you all are understand about this example problem.